There is a misconception so deeply woven into the human imagination that it has survived decades of science fiction films, centuries of philosophical dreaming, and even leaked into the conversations of serious researchers. The misconception is this: that the space between the stars is empty, that it is a silent, vast, perfectly open corridor, waiting for a sufficiently advanced civilization to simply push hard enough and cross it. That if you build a powerful enough engine, if you generate enough thrust, if you solve the engineering problem of propulsion, the galaxy opens like a highway and you arrive. This image is wrong. Not slightly wrong, not wrong, in a minor technical footnote kind of way. Wrong in the most profound, absolute, physically irreversible sense that the laws of nature allow. And when you see why it is wrong, when you feel the full weight of what the universe has placed in that path of anything that moves fast enough, you will never think about the stars the same way again. Let us begin not with the ship, not with the alien, but with something far older and far more patient. Let us begin with light that has been traveling for nearly 14 billion years. When the universe was extraordinarily young, a few 100,000 years old, the plasma that filled all of space finally cooled enough for electrons and protons to combine into neutral hydrogen atoms for the first time. When that happened, the universe became transparent. The fog lifted and the radiation that had been trapped inside that dense, hot, opaque plasma was suddenly free to travel. It poured outward in every direction, simultaneously filling the entire volume of space with an unbroken uniform sea of photons. That radiation never stopped traveling. It has been moving through the cosmos ever since that moment, stretching and cooling as the universe expanded, losing energy as space itself grew larger. Today, that ancient light is still here. It is everywhere. It surrounds you right now. It passes through the walls of your home, through your body, through every cubic centimeter of interstellar space, through every galaxy, through the largest supervoids between galaxy clusters. There is no location in the observable universe that is free of it. Physicists call it the cosmic microwave background radiation, and at this moment it is extraordinarily cold, hovering at roughly 2 hells for 7 degrees above absolute zero. Its photons carry almost no energy. They are the quietest, most ghost-like whisper of electromagnetic radiation imaginable, and under ordinary conditions, they are completely harmless. This is the field that an interstellar ship must move through. Now, I want you to hold a very specific picture in your mind. Imagine yourself walking slowly through a field on a warm afternoon. Floating throughout that field, suspended in the air at every height and in every direction, are microscopic soap bubbles. Billions of them per cubic meter, perfectly gentle, nearly weightless. As you walk, they drift against your skin and bounce away. You feel almost nothing. The experience is peaceful, almost pleasant. The bubbles are too soft and too light to cause any discomfort. Now imagine in a single instant you accelerate to 1 million miles per hour through that identical field. The bubbles did not change. The field did not change. The density of bubbles per cubic meter is precisely the same. What happens to your body is catastrophically different. That immense velocity, each bubble your body contacts is no longer a gentle floating film. The relative force of impact transforms each fragile microscopic object into something functionally equivalent to a steel armor-piercing projectile. They shred skin. They penetrate tissue. They generate violent thermodynamic friction. The field did not become more dangerous. Your speed made it dangerous. The environment was constant. Your motion was the variable. This is not merely a colorful analogy. This is a precise physical description of what special relativity does to the cosmic microwave background when you move through it at a significant fraction of the speed of light. Albert Einstein gave us the framework that makes this unavoidable. Special relativity tells us that motion fundamentally alters the perception of energy. This is not a quirk or an approximation. It is one of the most rigorously tested, most precisely confirmed results in the history of physics. When you move toward a source of radiation, the photons from that source appear shifted toward higher frequencies. This is the Doppler effect extended into the relativistic regime and at speeds approaching the speed of light. It does not shift frequencies modestly. It multiplies them by enormous factors. A photon that begins as a long, lazy, low-energy microwave photon can be transformed from the perspective of a fast-moving observer into something carrying millions of times more energy. The mathematics here are not subtle. The Lorentz factor, the number that describes how dramatically space and time distort for a moving observer, grows without limit as speed approaches the speed of light. At 90% of light speed, the Lorentz factor is roughly 2, 3. At 99% it climbs to about 7. At 9% it reaches over 22. At 99% it exceeds 200. And as the Lorentz factor grows, the energy of every incoming photon grows with it, multiplied by that same factor. So let us follow what happens step by step as a highly advanced ship accelerates toward a distant star. At relatively low speeds, perhaps 1% of light speed, the cosmic microwave background ahead of the ship is shifted slightly upward in frequency. The photons are still in the microwave or infrared range. They carry more energy than they did at rest, but the amount is manageable. The hull absorbs this radiation as modest heat. The effect is real, but not catastrophic. As the ship pushes to 10% of light speed, the shift becomes more significant. The photons ahead are now in the visible range. The ship is traveling into what appears from its own reference frame to be a faint blue glow surrounding its forward hemisphere. The radiation pressure is increasing. The absorbed energy is climbing. The thermal systems are beginning to work. At 50% of light speed, the photons ahead have shifted into the ultraviolet range. They carry far more energy. The forward hull is now absorbing radiation that can begin breaking molecular bonds. The ship requires active thermal management simply to maintain structural integrity. The gentle 7-degree background has become from the ship's frame something considerably hotter and more energetic. At 90% of light speed, the photons ahead are in the soft X-ray range. The Lorentz factor is over 2. Every square meter of the forward hull is absorbing X-ray radiation continuously and selfly uniformly from the entire forward hemisphere of the sky. This is not a beam from a single source. It is a perfectly uniform flood coming from every forward direction simultaneously because the cosmic microwave background fills all of space in all directions with equal density. There is no angle from which to approach the target star that avoids this radiation. There is no shadow to hide in. The X-rays penetrate materials, ionize atoms, damage molecular structures. The power load on the forward hull is enormous. At 99% of light speed, the photons ahead have been blue shifted into the gamma ray regime. The Lorentz factor is over 7. Every single one of those ancient, nearly dormant microwave photons, the ones that are so cold and harmless from a stationary frame, now arrives at the hull carrying the energy of a hard gamma ray photon. The forward hemisphere of the ship is being continuously bathed in lethal ionizing radiation of the kind produced by nuclear reactions. The power being deposited into the hull per unit area is enormous by any engineering standard. No known material can withstand indefinite gamma ray bombardment without progressive atomic degradation. The crystal structures of metals break down. Composite materials fracture. Polymers disintegrate. The forward face of the ship is being systematically dissolved at the atomic level, not by any specific weapon or targeted attack, but by the universe's oldest and most uniformly distributed form of light. And this is before accounting for the matter content of interstellar space. Space is not even between the cosmic microwave background photons truly empty. There are hydrogen atoms, typically 1 per cubic centimeter in the denser regions of the interstellar medium, and perhaps 1 per 10 cubic centimeters in quieter regions. At rest, these atoms are invisible obstacles, too sparse and too light to matter. But at 99% of light speed, each hydrogen atom the ship encounters has interstellar medium, and Theresia was to work as reference frame, been accelerated to a relativistic energy. The collision of the hull with a single interstellar hydrogen atom at these speeds releases energy comparable to a high-energy cosmic ray particle impact. Over the vast distances of interstellar travel, the hull collides with these atoms continuously, and the cumulative effect is a steady erosion of the forward surface by high low-energy particle bombardment, layered on top of the already overwhelming gamma-ray flux from the blue-shifted cosmic background. Now let us add the thermodynamic dimension, because the problem is not merely about radiation, damage to materials. It is about the fundamental nature of energy flow. Thermodynamics tells us that when energy flows into a system faster than that system can, radiated away, the temperature of that system rises. The forward hull of the ship is absorbing gamma radiation at an extraordinary rate. That energy must go somewhere. It heats the hull. The hull radiates heat as infrared radiation attempting to reach equilibrium. But the rate of energy input from the blue shifted cosmic background far exceeds any plausible rate of radiative cooling. The whole temperature rises toward and then past the melting points of any known material. The surface begins to ablate. The structure loses integrity. The ship, regardless of how advanced the engineering, is being thermodynamically overwhelmed, not by any external threat, but by the universe's own relic radiation field, amplified by the ship's own velocity. This is the fundamental point that science fiction consistently and rather dramatically misses. The barrier to interstellar travel at high speed is not primarily about propulsion. Building a powerful enough engine is an engineering challenge, and one can at least imagine sufficiently advanced engineering overcoming it over long time scales. The barrier is about the physics of what space already contains and what velocity does to your perception of it. You cannot engineer your way around special relativity. You cannot design a whole material that is immune to gamma radiation and indefinite continuous exposure. You cannot reach a sufficiently advanced level of technology that allows you to travel fast, enough for the journey to be biologically reasonable while simultaneously surviving the thermodynamic consequence of that speed. The universe does not simply stretch between the stars like a passive, empty backdrop. It is filled at every point with the ancient birthlight of the cosmos itself. And that light, gentle and cold, to the stationary observer becomes a lethal thermodynamics wall for anything moving fast enough to cover galactic distances in a biologically meaningful time frame. The scales of the galaxy are protected not by any external enforcement, not by any designed or deliberate mechanism, but by the automatic, inevitable, mathematically unavoidable consequence of combining relativistic motion with a universe that has been glowing faintly but universally for nearly 14 billion years. This is why the silence of the cosmos makes a different kind of sense when you look at it through the lens of physics rather than through the lens of disappointed expectation. The question has always been, where are they? The assumption beneath the question is that space is crossable. The assumption is that speed is the only barrier. The assumption is that a civilization advanced enough simply arrives. But the photons disagree. The thermodynamic gradient disagrees. The Lorentz factor disagrees. The ancient light that fills the whole of space disagrees quietly, uniformly, and at the speed of light, which is to say, it disagrees in every direction at once. Stars are not waiting to be reached. They are protected by the very physics that created them. And the next time you look up at a clear night sky and feel the pull of those distant lights, it is worth knowing that the space between you and them is not empty. It is full of the oldest light in existence. Perfectly cold, perfectly harmless, perfectly patient, perfectly lethal to anything moving fast enough to matter.